Welcome to week 6 of this Apex Learning, and that we are focusing on 9.3.3, the spontaneity of a reaction. It's actually the last kind of section of Unit 9 that we will focus on this week. As a reminder, there is a practice that's kind of due this week, kind of like the journal that was done before, that you have to submit it for credit in the grade book to your mentor teacher or something like that, but let's get going. So spontaneity of a reaction. So spontaneity, spontaneously, or spontaneous, all those means just mean does it just happen on its own? Okay. So if a reaction happens on its own without added energy, it's called spontaneous reaction. And a lot of times is so ice does melt spontaneously above 0 degrees, but not below 0 degrees Celsius. So they're trying to ask you, why does ice melt kind of on its own at some temperatures, but if it's below freezing, if it's really cold, why won't ice melt? Think about it. It has to do with temperature. That's what they're trying to get you to say, the whole idea. Now, temperature is a big part of what happens. Remember, temperature is the average kinetic energy, so really we're kind of talking about energy in a sense of that's really what's happening. So even if we add heat, if ice is below is at -10, the ice is still going to melt because you're adding this energy, this heat, even though it's below freezing point. So temperature is a big part of determining. And so we're going to combine the two things that we've been talking over the past weeks, enthalpy and entropy, and what temperature. So there's kind of 3 different factors that we look at when determining if a reaction is going to happen on its own, or do we have to add in something to make it happen, or to force it. So like we said, enthalpy and entropy are two main factors in which something is spontaneous or not. Okay, so we're going to kind of combine what's happening. So using our exothermic, endothermic from weeks before, which is more likely to be a spontaneous reaction? Okay, well, think about it. If something requires heat to be put in, like an endothermic, if I have to put heat on a stove to require something to happen, it's not going to happen on its own. It's not going to be spontaneous. So heat being released, exothermic, that's the spontaneous one. That's going to happen on its own. Okay, because it doesn't require that energy to come in for it to happen. That's the endothermic. Now, if we're talking about entropy, remember the randomness, the chaoticness, which one's more likely to something like spontaneous, which I in my mind often think something to happen on its own. Remember, in the last unit we were talking about that stuff tends to be more chaotic, more random. So it would be an increase because it wants to go that way. It wants to be more random, more broken, more stuff spread out. So that's what we kind of leave that at. Okay, so this is a nice little video, kind of puts it in perspective of what's going to happen when we have if a solution can form, even if it's unfavorable. So we're going to talk about if something's favorable, it's more likely to happen, or if it's unfavorable, where it might not happen as well. Okay, because we're all talking about do reactions kind of take place. So watch this video. It's helpful along the lines. Okay, and it'll help explain a little bit more. So what we do, of course, we had to come up with a formula to kind of calculate if a reaction is going to happen or not. And so we called it the Gibbs free energy, and it connects the enthalpy, which is change in H, the change in entropy, which we just learned, and then now we add in temperature of a reaction, and gives us a way to determine if it's going to be favorable enough for the reaction to happen, to occur. So we give it this kind of formula, the change in G. Remember, whenever we see a triangle, it means change, so a difference. The change in the enthalpy minus temperature times entropy, the change in entropy. Okay? So it just depends on this. This is our kind of formula to do forward. So if it's negative, the end result, the change in G, the Gibbs free energy, is negative, that reaction is going to be spontaneous. It doesn't need energy to happen, and it's just going to more happen on its own. But we do get energy from it. Okay? If the change in G at the end is positive, the reaction is going to be non-spontaneous, meaning it's not really going to happen on its own. And the value that we calculate of the G is going to be the amount of energy that must be added so that that reaction can take place. Okay, so we will get a value in this. Temperature, this T, is always going to be in Kelvin. That means that it starts at 0. Remember, the absolute 0 is Kelvin. You have no negative numbers, and the temperature is always going to be positive. We need that because if temperature was a negative, like degrees Celsius or Fahrenheit, it would mess up kind of the end result on whether or not the temperature is going to happen. So that's kind of why Kelvin, we need it to be, because it does not have a negative temperature. Okay? So we can start looking a little bit on this calculating, and this whole idea that the signs of both of these, the enthalpy and entropy, determine whether it's going to be positive or negative. So if we have a negative enthalpy and a positive entropy, it will always lead to a negative G, and a spontaneous will always happen. And then down here, based on the equation, which type can never be spontaneous? So we have to kind of play around in our mind. If I have a negative this one, a positive this one, which one does it end up being? So if we have this being positive and this being negative, let's try C. Yep. So if change in H is positive and change in S is negative, there's no way that the change in G can be negative as well, so these will never be a favorable reaction or spontaneous reaction. So it starts going into this in the next few, I'm going to show you before they start calculating towards the end, but they start giving you, if you have, a negative change of H, but a positive this one, it'll tell you always spontaneous. If you're positive, negative, it'll be never spontaneous. And then these two, when they're both the same sign, it really depends on the temperature. Temperature is always a positive factor, but if you have a high temperature, low temperature, it's going to determine what overall it will be. So temperature becomes important for reactions that may not always be spontaneous. Okay? So the last bit here, we have favorable factors that occur spontaneously, and it can be a result of both enthalpy and entropy being favorable, or just one of those factors being favorable. So it kind of determines, you can either have enthalpy favorable, entropy favorable, or both enthalpy and entropy favorable as well. So if water evaporating on a summer day, we're going to look at that one as it's going into a gas, and it's going to entropy favorable. Okay. Now you could try some of these on your own. It'll either let you put them there or let you not, on whether it's right or wrong. Then we have the salt in a hot pack. It's dissolving when the pack is activated. So if something for like a heating pad or a hot pack when you're trying to get something hot, it actually has both of them being favorable. A hot metal pan that cools has both as well. A glass feeling warm as the salt precipitates from water. It's being an exothermic, and enthalpy is favorable. Water condensing on the outside of a cold glass is also enthalpy favorable. Okay? So I'm going to kind of leave it off here and give you a little preview of the part 2 that I'm going to post later. But it's you starting to put actual values for this, and kind of have a little temperature, and you can change and different things going on, and I'll explore it more later. But of course, with any formula in science, you're going to need to plug in values to kind of get the result with that. So good luck, and I will talk to you in part 2.